Hey guys, how you doing? Welcome back to my channel. Today I am going to be teaching you about Async IO, and I've been regularly posting videos on Python. So Async IO is an interesting topic. I did not know what it meant until a few days ago, and I decided to learn that, and I wanted to share it with you, which is basically what my channel is. Like, I share what I learn with awesome people like you. Okay, so now let's jump right into the topic, which is Async IO. Okay, simple definition here. I don't have uh, a lot. So first of all, Async IO is a method to to basically do a concurrent programming, right? What that means is, okay, let's say you have two programs, right? Let's say you have two programs and each program takes about 5 minutes. And let's say you execute program A first and wait for it to finish. And then you execute program B and then you wait for it to finish. So that will take 5 minutes plus 5 minutes, that's 10 minutes. So that is called sequential execution, right? And parallel execution would mean that you execute program A and then you execute program B, and each will complete in 5 minutes, right? So the first one will complete in 5 minutes, and parallelly the program B will complete in 5 minutes. So instead of 10 minutes, the total time now is basically only 5 minutes. So that is, that is sort of common sense, right? So using Async IO, you can sort of like implement concurrent programming, uh, by executing functions concurrently, right? So, and I'll show you a good example. I have an interesting example, and hopefully that will make it clear for you. Okay, so now, of course, like Async IO is the name of the package, the Python package that we are going to use. So that's the definition, and it sort of like functions like an API, and that is what you're going to use to concurrently execute functions, right? So now we're going to look at how to install these, or what packages do you need to install basically. And second, we're going to look at an example where your Python program is executing functions in a sequential manner, and we'll take the same program and we're going to convert it into a concurrent execution or a parallel execution using Async IO package. Okay, sounds good. Okay, so first actually let's go ahead and install these packages. So I'm just using a pip install method. Pip is basically the package installer, so that comes along with the Python installation, right? I think these days it's part of the Python installation. Earlier it used to be a separate installation. So yeah, so pip install upgrade, right? So let's actually, usually I use repl.it to sort of like walk through examples in my video. So today I'm going to be using my Python installation on my laptop actually. So I have Python 3.7.6. This is not the latest version, right? But I think that should do. And this Async IO feature or Async IO package has gone through a lot of changes in the recent version. So yeah, so understand the basic functionality of it, and when you use it in like let's say a newer version of Python, do check the Python documentation. Okay, So now let's actually go ahead and install the packages that we need, which is AIO HTTP and AIO files. So that's going to install a bunch of packages. It might take a few seconds. So by the way, I'm using a virtual environment, and this is not going to mess up my basic Python installation that's on my laptop. So I'm using a virtual environment, right? So the packages are installed successfully, right? So now let's jump into the example. So before I show you the code, so let me show you what I'm trying to do here. So let's say we're talking about your morning routine here, right? In the morning you wake up and you go to your kitchen, and let's say the first thing you do, like first after brushing and stuff like that, you go to your kitchen and make coffee, right? And you make coffee, which let's say usually takes 5 minutes or whatever. For the purpose of demonstration here, let's assume that it takes 10 seconds. Right? Let's say you have a super duper coffee machine which makes coffee in 10 seconds, and then you move on to make a bread toast. Like you go to your toaster and then you make a bread toast, and then let's say you have a very modern toaster that does the job in 10 seconds again, right? Okay, so now that's basically, let's say, your morning routine. You go to the kitchen, make coffee and make toast. So each of these tasks take 10 seconds, and let's assume first that you do these tasks in a sequential manner, right? So you make coffee and then you make toast. So totally it's going to take you 20 seconds, right? Now let's actually see the same thing happen in my code, right? So this is the code. All I have is I'm importing this package called time, right? Just to measure how long it takes, right? So, and then in the main part of my code, of course these are definitions. So in the main part of my code I'm calling one function called morning routine. This is the function, and which in turn calls make coffee first, because in our example here we are making coffee first and then we are making toast, right? So morning routine calls these two functions one by one in a sequential manner, and we kind of get the start time, we get the end time, and then we get the difference between the start time and end time, and that's going to give you the elapsed time in seconds, right? So let's go ahead and run this example, right? So basically now you're making coffee, so the program is making coffee, right? And then it's going to take 10 seconds, and then now we're done with making coffee, right? So now it's making toast, and it's done with making the bread toast. So the total time it took is 20 seconds, which is kind of sneaked in. Like if you look at this make coffee and make toast function, it's a simple print statement with the sleep statement or sleep command inside, just to sort of like mimic the task. Like sleep here means that we're making coffee, sleep here means we're making toast, right? So we're sort of mimicking the functionality, the task, right? So the total time it took for you is 20 seconds, right? So now I'm going to show you another example where or another piece of code where we basically take the same thing and we convert it into async IO, right? So what that means is this one. So you still have the same two functions, and you can see that I have prefixed async in this for these functions, right? So this is a sort of like a mandatory thing. So now sometimes these functions are referred to as subroutines, because this is the main routine and these are the subroutines which achieves the ultimate goal, which can be whatever. Here it's the morning routine, right? And subroutines are make coffee and make toast, right? Whereas when you talk about concurrent programming, so then basically you would call these functions coroutines, just because coroutines are pretty much the same thing, but then they are going to be executed concurrently or in parallel, right? So now let's say actually you have the same two functions, and then you have the same morning routine function which calls those two functions in a slightly different way. So this is why you can see that I imported async IO and imported time package, right? And again we're pretty much following the same sequence of steps actually, right? So getting the start time, calling the morning routine just in a slightly different way called async IO dot run. So this is an API. So just why I said async IO is an API to manage coroutines. So these are our coroutines, right? So what's going to happen is so I'm calling this morning routine using this API, and I'm getting the elapsed time, which is the difference between start time and end time, and then I'm printing the amount of time it took, right? So let's go ahead and execute the program, right? So the async example code that I was talking about. So yep, so let's go ahead and execute it. And as you can see, instead of executing those functions sequentially, it's already it clearly shows that it started making coffee and also started making toast, and then this function finished, so it went back there, and then the making toast also finished. So this is you can definitely see the difference between this and the sequential execution, right? So if I ran the sequential execution, the output would look like this, right? So it starts making coffee and then waits for it, starts making toast and then waits for it, right? So you can clearly see the difference between sequential execution and parallel execution, right? Because this is somewhat like you go and then you put your coffee, you turn on your coffee maker, and then you go to your toaster and then you start the toaster, and then you wait for the coffee machine to finish, and then you wait for your toaster to finish. So this is sort of like multitasking, right? So that's the difference actually. So let's go back and then understand how this is happening in the code, right? So now basically this is the main portion of the code. So we get the start time, and then we call the morning routine function or coroutine, right? And then which basically it calls these two functions, and we're just saying execute these functions asynchronously. So we're going to basically call make coffee first, and then which starts to make coffee. And while that is happening, so it says, okay, now go back and uh, execute some other tasks actually, and then uh, and then come back here, sort of like that. So the control gets passed back here, and then now it's executing make toast. So that, which is why you're seeing, right, you're seeing start making coffee and start making toast immediately, right, because the control is passed back to the line where it was invoked. And now both the functions are running concurrently, and then finally both of them finish, right? So, and then you can see that a sequential execution took 20 seconds, a parallel execution or a concurrent execution took 10 seconds, right? So, and hopefully that made the concept of async a bit clear for you. I know it's a little bit tricky, but then I kind of like took a very simple example and then explained it to you. Okay, if it's not clear, comment below and let me know, and I will see you guys again next week with another Python video. And if you haven't subscribed yet, please go ahead and do that, and hit the like button and bell icon, and also kindly share my videos on LinkedIn or Facebook. Thank you.